Welcome to this guide on data balancing in Hadoop Distributed File System, or HDFS. In large-scale systems, data often becomes unevenly distributed. This can happen due to adding or removing nodes, using disks of different sizes, or inconsistent data write and delete patterns. As a result, some nodes may become overutilized, increasing the risk of failures and potential data loss. On the other hand, underutilized nodes lead to wasted storage resources. To address these challenges, HDFS provides two key balancing tools. First, the HDFS Balancer, which balances data at the cluster level across different data nodes. Second, the Disk Balancer, which balances data within a single data node across its internal disks. In this presentation, we'll explore how both of these tools work, their architecture, configurations, and best practices for optimal cluster performance. The HDFS Balancer operates by moving blocks from overutilized data nodes to those that are underutilized. It uses a configurable balance threshold, typically set to 10% by default. This means the node is considered imbalanced if it's 10% above or below the average utilization. For example, if the average cluster utilization is 40%, the threshold range would span from 30 to 50%. Here's how the workflow unfolds. First, the balancer queries the name node to analyze the cluster's block metadata. Next, it identifies source and target data nodes for rebalancing. Then, it directly transfers blocks between these nodes. Bandwidth throttling is used throughout the process to minimize performance impact. Finally, the balancer stops once all nodes fall within the acceptable threshold range. Unlike the HDFS Balancer, which works across the cluster, the Disk Balancer operates within a single data node. It ensures even data distribution across that node's disks, especially important when new disks are added or data patterns become skewed over time. The default policy is round-robin, which can be switched to the available space policy in heterogeneous environments. The process begins with the planning phase. You generate a balance plan using this command: HDFS Disk Balancer Plan D-non-E, example, com bandwidth 50 threshold %5. To execute the plan, use HDFS Disk Balancer execute /system/disk balancer /d-non-E plan JSON. You can also monitor or control the disk balancer with commands like query and cancel. Both balancer tools can be fine-tuned for better performance. For the HDFS Balancer, adjust the following parameters. Increase bandwidth from 1 MB per second to up to 1000 MB per second using DFS DataNode balance bandwidth per sec. Increase the number of parallel threads with DFS Balancer mover threads. Lower the balancing threshold to 5% for stricter control. Move larger blocks by changing DFS Balancer max size to move from 10 to 100 GB. For the Disk Balancer, edit the HDFS site XML configuration. Enable the feature using DFS Disk Balancer enabled. Control throughput using DFS Disk Balancer max disk throughput in MB per sec. Adjust the threshold with DFS Disk Balancer plan threshold %. To overcome bottlenecks in traditional node pairing, HDFS supports advanced strategies. One such method is percentile-based pairing. This is controlled with the setting DFS Balancer separate percentile, often set to 0.6. This approach can deliver up to 5 times the throughput of standard balancing. Additionally, you can prioritize nodes. Sort overutilized nodes in descending order. Sort underutilized nodes in ascending order. This prevents redundant pairing with mid-utilized nodes. For visibility, use commands like HDFS Disk Balancer Query or HDFS DSAdmin Report to monitor and troubleshoot operations. To get the best performance from your balancing operations, follow these best practices. First, always run balancing jobs during off-peak hours, ideally after node or disk changes. Adjust your bandwidth according to system load. Use up to 1 GB per second when the cluster is under light load. Reduce it to 20 MB per second to avoid congestion during high load. Common issues include slow balancing. This may require increasing mover threads or inspecting the name node for delays. Post-balance queue. Consider lowering the threshold value. Disk errors. Adjust DFS Disk Balancer max disk errors to tolerate transient disk issues. Let's compare the two balancer tools. Scope. The HDFS Balancer operates across the entire cluster, while the Disk Balancer focuses on individual nodes. Trigger conditions. HDFS Balancer reacts to node-level storage imbalances, while Disk Balancer addresses imbalances between local disks. Configuration parameters. The HDFS Balancer uses threshold, whereas the disk balancer uses bandwidth and threshold percentage. Performance impact. The HDFS Balancer stresses the network, while the disk balancer primarily consumes disk I/O. Here is a quick reference for important commands. For HDFS Balancer, set bandwidth. HDFS DF set balancer bandwidth 209,715,200. Run the balancer. HDFS Balancer threshold 5 policy DataNode. For disk balancer, create a plan. HDFS disk balancer plan dnoni example comout/tmp/plan JSON. Execute the plan. HDFS disk balancer execute/tmp/plan JSON. Monitor status. HDFS disk balancer query dnoni example to conclude. The HDFS Balancer ensures optimal data distribution across the cluster, reducing the risk of node overload. The disk balancer resolves imbalances within individual data nodes, preventing localized hotspots. For large, dynamic environments, it's recommended to use both tools in combination along with percentile-based tuning to maintain long-term cluster health and efficiency. This dual approach guarantees sustained performance, improved reliability, and smarter resource utilization across your Hadoop infrastructure.